Earlier this year, we installed an Acudyne Easy Puller on the CNC lathe. The Easy Puller is a unique product in that you only have to program a diameter offset when you change stock, simplifying the puller setup. Acudyne publishes a table, and this is it. When I implemented this in the post-processor, I ended up using a case statement to load the appropriate offset depending on the bar. But ultimately, I wanted to be able to get a more accurate offset. To understand the offset values published in Acudyne's table, I plotted them in Desmos, and I came out with what looked to be a near perfect arc. So I added a variable slider in Desmos and began looking at what my arc might be. And what I ended up with looked more like a parabola than an arc. At first glance, the parabola 0.3 times x squared looked like the perfect solution. But something just kept nagging at me. I couldn't quite wrap my head around how two round rollers going over a round bar would create a parabola shape. So I went ahead and plotted the metric values. And this is where things really fell apart. So I contacted Acudyne tech support regarding the discrepancy between the inch values and the metric values. And they sent back a revised table that looked much more accurate. These values appeared to plot an arc that I had expected, but the values didn't appear to be as clean as what I would have expected. I quizzed Acudyne's engineer about this, and he said that he had generated them from within his CAD package, so I suspected there may be some rounding issues. So I measured the Easy Puller and put the values into the CAD package and began playing with it to get an idea of what it should look like. And one thing that was very obvious right from the go is that it should be a matter of solving a right triangle. And it took a little bit for me to realize that the values that I was solving for were radius values. And obviously the published tables would be in diameter because most CNC programmers program in diameter on the lathe. If you think back to Pythagorean theorem, b equals the square root of c squared minus a squared. I solved a few points and went ahead and plotted them, and you can see my arc is very clean, and this is what I would have expected. This is the code I ended up implementing in the post-processor. I started with a few variables. Pivot distance is the distance between the pivot points. The arm length is 1¼ inches, and the roll diameter is 1 1/16. The zero origin is actually the length of side B when the Easy Puller is at rest. Side C is just my arm length, 1¼ inch. Side A is the roll diameter minus the pivot distance plus the stock diameter divided by 2. Side B is the square root of side C squared minus side A squared. Because my post-processor expects the offset to be a radius value, simply subtract side B from the zero origin and you're done. Since implementing these code changes in the post-processor, the Easy Puller has worked flawlessly. Thanks for watching.